I want to go ahead and introduce our first speaker here. And our first speaker is Cesar Rodriguez. He's the head of developer advocacy at a cool cloud security startup called Accurics. Now, when I first met Cesar, he wanted to share with me a tool that he had written. He's the creator of the open source Terrascan tool, and he was sharing with me kind of his roadmap, the plans for upcoming releases, and I was really excited to hear about everything that they've got going on in the works with this free open source tool. So with that, I'm going to go ahead and turn it over to Cesar, and he's going to talk all about securing serverless.
All right. So hello, everyone, and thanks for joining us today. My name is Cesar Rodriguez, and like Frank said, I'm the head of developer advocacy at Accurics. So a little bit about me. I've been working on the security space for the last almost a decade, securing public and private clouds in the military and financial industry, and working on starting cloud security programs from scratch and growing them to support the security of thousands of resources across multiple regions and cloud providers. And the first time I heard about cloud computing, I was finishing up a big project where we built and stood up a data center running everything on the latest and greatest virtualized infrastructure. And I didn't really understand the concept of public cloud. To me, the public cloud was just about using other people's computers, so another way to collocate servers. And I thought cloud was just another buzzword. So after my first big cloud migration project, I realized that the power of the cloud comes from having an API that lets you control and automate every aspect of the environment, from provisioning and configuration of your infrastructure to securing that infrastructure. So today we're going to discuss how to secure those APIs by using infrastructure as code to manage one of the most typical types of workloads in cloud environments, which is serverless. We're going to use an open source tool called Terascan to do this. So the term serverless itself is a little bit confusing. And given my experience with cloud, once I heard this term, it quickly clicked, because even though the word serverless itself is misleading, using serverless workloads doesn't mean that there aren't any servers involved. It just means that we shifted the management and the operations and upkeeps of those servers to our cloud providers. And now developers can focus on writing code that's going to be executed on the platform, securing that code, and making sure that security best practices are followed for the serverless platform that you choose. The other benefit of serverless workloads is that you get charged by consumption. So for the most part, these are going to be way cheaper than traditional workloads using infrastructure as a service, where you're keeping the infrastructure turned on 24/7, even though it might not be used the whole time. So you might be asking yourself, what does serverless means to security? And there's a few things that we need to wrap our heads around when securing serverless workloads. The first thing is that you're shifting the handling of platform level vulnerabilities and below to your cloud provider, but you're still responsible for writing secure code and for any security issues in your code's dependencies. You also need to make sure you understand and follow security best practices when using and configuring your serverless platform of choice. And we'll discuss what this means in the presentation. And you need to understand how serverless fit within your overall threat model, and if the risk of shifting the responsibility for managing the platform that runs your code to your cloud provider is acceptable and increases your security posture, or if it's unacceptable and losing control and observability of potential issues affecting your environment is not acceptable. So for most organizations, we've seen that the cloud providers will provide really good vulnerability management and reliability of their workloads, and using serverless will actually help in their security. So to have a secure serverless application, you want to make sure that any code used to configure the platform is secure by default. For cloud infrastructure, that code is infrastructure as code. And these are tools like Terraform, CloudFormation, Azure Resource Management, Google Cloud Deployment Manager, where you can declaratively define the target state of your infrastructure, and the tool will take care of exercising the cloud provider's APIs to achieve the target state that you define in your code. So the open source tool that I created that can help you scan your infrastructure as code templates and follow security best practice is called Terrascan. And it's just a static code analyzer for infrastructure as code that currently supports scanning of Terraform and Kubernetes templates. We wrote the tool around 3 years ago to help just democratize cloud security and provide an easy way to scan infrastructure as code. And here are some of the features that Terrascan provides and can help you with. It easily integrates into your workflow, and it's packaged as an executable that you can run locally or as part of your CI/CD pipeline. It can also be executed in server mode, which allows you to govern infrastructure as code scanning across your organization just by having a central hub with rules for your organization that you can just scan all of your code. The tool leverages the Rego language from the OPA project. So that's what we use for our policy engine. So we standardized in the way we implement policy as code. We have right now over 500 policies included as part of the Terrascan open source project for scanning things like AWS, Azure, GCP, even GitHub configurations using Terraform and Kubernetes. And we're frequently updating it with more. We also wrote the tool so that it's easy to add support for additional IAC providers. So currently we support Terraform and Kubernetes. And the idea is that the policies that we write using the Rego language will be cloud agnostic. So if we write a policy for a specific cloud provider to fix an issue in that cloud provider, we want the policy to apply whether you're using Terraform or CloudFormation or whatever the cloud provider provides. So now let's see how Terrascan works in action. So for this demo, I want to build a website for Terrascan that randomly displays the logo with a white or a dark background. And I'm going to incrementally increase the resources in this architecture for the demo. And initially, it's just going to be a public S3 bucket where I want users to be able to access the bucket directly from the public internet. So let's see how this works. And the code for this demo is in this repository, which I just made public, so anyone can follow. And this is what it looks like for this first iteration. Right now, I have a s3.tf Terraform file that it's creating a AWS S3 bucket that has a public read ACL, meaning anyone can read objects from this bucket. And from the public internet, it has a website configuration with an index.html, a bucket policy that allows everyone to get objects from the bucket. And it has a few static assets. I have an index.html file with a public read ACL and the logo in white and the logo in dark. So I have a Terraform wrapping script here. So I'm going to go ahead and deploy this. And in the meantime, I'm going to open a new terminal so we can scan it with Terrascan and see what it finds. So let me do that again. So if running Terrascan, like I said, it's just an executable. It's reading Golang. So I wrote Terrascan scan /d, which is the shortcut for the cloud provider. This is AWS, and -d, which is the shortcut for my directory here that has infrastructure directory that has all of my Terraform files. So if we see real quick, let me see if Terraform finished. Yep. So I'm going to open this link and it opened in my other window, but this is basically what we get. An index.html file. It's not fancy or anything, so I don't get the changing background like I wanted. So that's what I get with S3. Going back to what Terrascan found. So the default output is in YAML, and it can change. You can change this to JSON or XML. So what I found is that I'm not enabling versioning in my S3 bucket, which is important because if I accidentally delete objects from this bucket, they would be forever deleted. When you enable versioning, it's just a deletion marker so you can retain your data. Also, the S3 bucket is set as a website, so it's leaking data to the public internet, and all users have free access to the bucket, and everyone can have the get objects from this bucket. So not good. So what I want to do next is, let me go back to the presentation if I can find it. So I want to put a Lambda function in front of my bucket and make that bucket private for my next iteration. So let's see how that works. Out. I have another branch with this code. So here I fix all of the issues that Terascan was telling me on this S3 bucket. I made it private. I enabled versioning. Instead of having an allow, I put a deny action here. And I made my objects private. And then I added this lambda.tf file. And I also added, and I'm not going to go over this code, but I also added code, a Python code that allows me to randomly get an object, download objects from that S3 bucket, which is the 2 static images from the bucket, and just return one of them randomly. So let's look at the Terraform now. So I'm inputting an environment variable with the bucket name to this Lambda function. And the Lambda function has an IAM role attached to it that allows it to create logs. And it also allows it to get objects from that S3 bucket. So let's go ahead and deploy this. And while it deploys on my other terminal, I'm going to see what issues we find right now. So here are the issues that we find. So the first issue is that the Lambda has variables that are not encrypted using KMS, which is AWS's key management service with customer managed keys. It also is not in a VPC. And the reason this is important for Lambda functions is 2 reasons. One is that if for any reasons you have a workload where you need to control egress access from that workload, you want to make sure that that traffic is routed to your VPC. And also, if you want to have more observability of what your Lambda functions are accessing, having VPC flow logs can help you with that. I also didn't enable tracing with X-ray, which is useful. So the other thing with Lambda is that Lambdas can't be made publicly available by default. So I can invoke it from my CLI, and that gives me a response file. So here's the response file. But this is not the user experience that I'm looking for. So the last service that we'll show you here for my final architecture is I'm going to put an API gateway in front of that Lambda function. And what the API gateway can help you with is have a access control at the gateway if needed. We're not needing it in this use case. It also can help you putting rules like throttling for your APIs if you need that. And it will help me in this case expose that Lambda function to the public internet. So let me go ahead and check out the branch with my code. Gateway. So in this branch, I fixed the KMS ARN that it was asking me for. I'm placing it now on a VPC. I am giving it access now to create a network interface, which is needed for making it available on the VPC. And then I'm also adding API gateway permissions to access the Lambda. So let's deploy that real quick. And I added this Terraform file for API Gateway. So let's see what Terascan can help us find on this Terraform file. Oops. Terascan infrastructure. Am I in the right one? Yep. All right. There we go, sorry. So this is the new run. So it's saying that the API gateway has no access logs enabled, which is important if you're trying, from a security perspective, to have visibility on what traffic is hitting your application. It also has a misconfigure CORS. So I misconfigured CORS because I allowed a star for all the origins that can access this. So let's go to the Terraform side real quick. Oops. Play this one more time. I'm not sure what I don't have permissions to do. And while we wait for that, I'm going to change for my final branch where I fixed this issue, which is my main branch. Right. And on that main branch, what I fix is now I remove the star from the allow origins, which is telling us that it will only allow traffic from the same origin of API gateway. And I also enabled access logs, which is here. So I created a CloudWatch log group, and I'm giving it a format for my access logs. So for some reason, I'm having a bug on my code. So let me see if now that we're in the main branch, it can run. So I'm going to go to the final slide and while this runs, because I have a bug on my permission issue on my code. But basically, these are I wanted to leave you with the cloud security risk categories that Terrascan can find and that you should be thinking about when you're looking at cloud security. The first one is data protection. You want to make sure that you look for any issues where data is not encrypted in transit or encrypted at rest. So things like we saw, making sure that KMS is enabled for your workload. Also, access management is really easy to, in a cloud environment, to make things public, even inadvertently. So you need to have security controls, especially at if you can put them in place when you're writing the code itself with a tool like Terrascan, so that you don't expose things like S3 buckets publicly accidentally. Next is network security. So having security controls around what ports could be open and which workloads can talk to which workloads, and last, visibility. So this is something that we may not think about, but it's really important to have things like enabling logging, enabling access logs, monitoring, and any monitoring options that are available, just so you have the visibility that you need, not only from an operational perspective, but also from a security perspective. So that's all I got today for my time. Thank you so much for having me. I'll be in the Slack channel chatting if anyone has any questions.